Hello students, today we're going to be talking about direct variation. It's 3.4 and 3.5, so please make this your title in your composition notebook. Okay, I'm going to write a definition up here on the board and I would love for you to copy it in your composition book. Direct variation. It's a special kind of linear function, which just means a line, linear function, that can be written in the form y equals mx. This is so important. Okay, so make sure you copy that down. Direct variation is a special kind of linear function that can be written in the form of y equals mx. I'm going to switch colors. Now if you remember, we said our m is always the slope. And we also learned a few different words for that in the last couple of weeks. One of them was constant rate of change. So slope and constant rate of change are the exact same thing. I'm adding a new term here, and it's the constant of variation. The constant of variation is the same thing as the slope, and it's the same thing as the constant rate of change. Okay? So don't let those three words confuse you. They all mean the same thing, and their letter is M. Their letter is represented by M. We're going to look at a few different types of examples of direct variation and some that are not direct variation. Okay, here are the examples I was just telling you about. I'm going to try to determine which ones of these are direct variation and which ones are not. So remember, our form was y equals mx. So at example number 1, we have y equals 1/3 x. 1/3 is our m. This is direct variation, right in the form of y equals mx. Over here we have x divided by y equals 2. I know this doesn't look like y equals mx, but we can actually solve for the correct form. So I have a y over here, so I'm going to multiply by y on both sides because right now I'm dividing by y, so the opposite is multiplying. So that crosses out both y's, and then I multiply by y on this side. So now I'm left with x equals 2y. Well, I'm trying to get the y by itself because it's y equals mx. So I have to divide by 2 on both sides. So if I divide by 2 on both sides, I get x over 2 equals y. Now that's very close. And if you remember, if we divide something by 2, it's the same as multiplying by. Exactly, I heard you out there. 1/2. 1/2 x equals y. And that is in the correct form, even though the y is on the other side. We could also rewrite this as y equals 1/2 x. So ding ding ding, yes, that is direct variation. Okay? Sometimes you might have to manipulate. That's okay. Let's look at number 3. Is this direct variation? No. This is y equals 2x plus 3. What makes this not a direct variation? This right here, the plus 3. We have to have y equals 2x. So this would have been direct variation, but since we have the plus 3 here, 3's out. No direct variation. Now, if you have a graph, perhaps, which one day you probably will, one thing that you need to know about this is if we have y equals mx it always goes through the origin. So direct variation always goes through the origin. So I might write that. Direct variation, dv, always passes through the origin. And if we remember, the origin is 0, 0, which is right there. Does this pass through the origin? Yes. And it's a line. That's great. So this is direct variation. What about this one? Here's the origin, and I don't see that line crossing through it. So no, this is not direct variation. Okay, so now I have tables up here. How on earth could I find out if these tables are direct variation if there's no y equals mx? Well, I'm here to tell you. So, I can again manipulate my equation so that I could solve for a different variable. So, if I have y equals mx, I'm actually just going to check these points and see if they have the same slope. Okay? So I want to solve for the slope. So I'm dividing each side by x. So the slope is always y over x. So all I'm going to do is find the slope of each point. So the slope is y over x. And so each of these slopes should be the same if it's a direct variation. And if they're not the same, they're out. Kick them to the curb, no direct variation there. Okay? So, switch colors. So my y is 6, and my x is 1. Okay? Let's check this one. My y is 12, and my x is 2. Y over x. This one, my y is 18, over x is 3. This makes sense because in rise over run, we are finding the vertical change, which vertical reminds us of y, over the horizontal change, which reminds us of x. So that makes sense, y over x, same sort of thing. So now I have these three slopes. Are these all the same thing? They are. So they all equal each other. Why? Because 6 divided by 1 is 6. 12 divided by 2, also 6. 18 divided by 3, also 6. So this one, we can keep. It's a direct variation. Okay, let's take a look-see at the other one. So again, we're doing the same thing. We're finding the slope using y over x. So our y over here is 8 over 2, 54 over 6, 80 over 10. 8 divided by 2 is how much? 4. 54 divided by 6 is 9. Oh, does 4 equal 9? No. So those, since those don't equal each other, this is not direct variation. Not even close. Out. So whenever you're given tables, remember to just put the y's over the x's and tell me if they, if the slope is consistent through the whole thing. This reminds me a lot of constant rate of change. Congratulations, you've almost made it to the end of the video. This is the last example. So this problem, y varies directly with x. I'm already telling you that. This is already told to you in the problem. Don't even have to worry about checking it. But I do have a question. So it says 2 yards of fabric costs $15. So how much does 7 yards cost? So I'm going to go ahead and put this in my table. 2 yards costs $15. Just getting this straight from the problem. So 2 yards costs $15. Now we said in our previous example that we can solve for the slope, and m always equals y over x. So we can always find what the slope is as long as we've got these 2 points. Or this is actually 1 point but it's an X and a Y, okay? So we've got one ordered pair, that's all we need. So we can use our Y is 15, so 15, plug in 15 for Y, and our X is 2. So 15 over 2 is 7.5. That's okay. That is A-okay now. We're not using rise over run. We can have a decimal now. You have graduated. Okay? So 7.5 is our slope. So what we can do, I'm going to scoot over to this side. I feel like this side's lonely. So since I have m, I can just write it in my equation. So y equals mx. That's my equation. So y equals, we're replacing our m with 7.5. 7.5x. Now, we're not done yet because it says how much does 7 yards cost? 7 yards is our x value, right? So I'm going to scoot down here. So we have y equals 7.5, and instead of x, we're going to put in 7 because that's what we're trying to find. How much does y, the cost, equal when we have 7 yards? So 7.5 times 7, I believe, is 52.50. And so that is our answer. So I'm going to write 7 yards, 52.50. That's it. So if you're given an x and a y value, you can put y over x and always find the slope. These are your practice problems for tonight. Just to briefly describe, number 1, which 1 or 1s is a direct variation? Could be 1, could be more than 1, you tell me. Number 2, tell me if this table represents a direct variation. And then number 3, Bill earns $15.50 per hour, represent this as a direct variation. Please take a picture of your practice problems and submit them to Edmodo.